Alright guys, for 10.3 we're going to get into an equation for an ellipse. So for today we're going to do three things. I'm going to focus on the first two, just analyzing ellipses with a center at the origin and then analyzing them with the center at h comma k, so just shifting the center someplace. So first of all, what is an ellipse? It's simply a collection of all points in a plane, the sum of whose distances from two fixed points called the foci is constant. So what all that means is, so here they show this picture of, this is actually a good way to learn what an ellipse is and how to make one. They show two tacks, right? These are like tacks that are here, and they put them on the axis there. And then you can imagine that there is this loose string kind of hanging between them. Okay, if you grabbed a pencil and, like they show here, and pull that string tight, okay, and then move it in a circular motion around those tacks, it will automatically create an ellipse. The distance anywhere here, anywhere. Here they just showed this spot here, P. The distance from here to this tack and here to this tack, that total distance will always be constant, no matter where you are. If you're over here, it's this distance plus this distance, right? So no matter where you are, you can imagine that rope just staying tight around those two tacks. It'll stay a constant. All right, so that therefore, since it's constant around some fixed, to these two fixed points in some center, I can create an equation for it. There's a pattern to it. Okay, so that's what we're going to do today. So theorem one is, here's an equation for an ellipse. Now notice, there's a couple things I need to highlight here because we're going to look at something specific right now. This is when the major axis, okay, the major axis is the longer of the two axes. So in this case, it's this thing, right? The major axis. And the major axis is along the x-axis, okay? An equation of the ellipse with center at 0, 0. Okay, so we're only looking at centers at 0, 0 right now. And the foci is at negative c comma 0, so they call that that distance from the foci to one of the points the value c. Okay, so c has to do with foci when you see a c today. And the vertices are at negative a comma 0, a comma 0. Okay, a is going to be the distance of the major axis. Okay, so the major axis is going to deal with a here. And we know what becomes interesting is when you line this up with the axis or the origin on a coordinate plane. What we see here is that you can form this right triangle, right? And we only need to form one of these to prove this out, because remember that the distances will always stay the same no matter where you are in this ellipse. Okay, so if we could do it on this axis here, then we can figure it out for the full ellipse. So notice that in this triangle, C is the distance from the center. Okay, so from center to foci is C. That's an important point. You might want to jot that down. From center to foci equals C. Okay, so once I know that C value, and maybe sometimes you won't know it and you're going to try to find that, but that's okay. They have to give you enough to find one of these things. And if you knew the distance, of the major axis distance is always going to be the distance from center to the vertice on the major axis. Okay, that's the A value. And then the B value is just the distance in the vertical direction. Okay, so we have vertices at negative a comma 0, so this value here, and a comma 0 on this one, but when we flip it, it'll be at B. Okay, so hopefully that'll make more sense here as we go, but remember this when we are solving these things. So let's go to the next example here. The first example, it says, find an equation of an ellipse with a center at the origin. Okay, so that's important. We know the center is at the origin. We know that we have one focus at 2 comma 0. Okay, so we have a focus that's here, and then we have a vertex at 4 comma 0, which is here, which means that if the center is at 0, what's nice is that we could just replicate that on the other side, right? So at 2, negative 2, we have a focus, and we have another vertex here at negative 4. Okay, so the ellipse is going around those 2 points through that. And our challenge here is going to be to find what this distance is, because what we've been given here is we've been given that C is equal to this distance here, which is 2. And we've been given that A in the major axis is equal to, the distance from the center to that, which is 4. And we have to find B. All right, so the first thing that I want to do with this is I want to find B. So to find B, remember that that in all of these equations that b squared is going to equal a squared minus c squared. Okay, so since I know a and c, I'm going to just say b squared is equal to 4 squared, which is 16, minus c squared, which is 2 squared, which is 4. So then b squared is equal to 12. All right. And really that's all I need to know. If you wanted to know the exact distance of where to graph this, like if you're going to graph this, then you take the square root of 12 and you'd know how far to go from center in the vertical direction. Okay, so now that I know this, I can write my equation. Now remember that my equation is in terms of b squareds, so I can leave that 12 there. So let's do this here. I'll do this in red. So we know that since this thing is stretched along the x-axis, that x is going to come first. We have x squared over a squared. A is equal to 4, so 4 squared is 16. We're going to add that to the y direction, so it's going to be y squared over b squared. Well, b squared is 12. We just found that. Okay, and this is always equal to 1. So that's the equation for this ellipse. And we're basically just going to modify that as we go today.